Hello student, welcome to our last lesson where we are going to look at uses of CRO. Now, cathode ray oscilloscope can be used in the following ways. 1, as a voltmeter, and number 2, to determine the frequency of an alternating current signal. How do we use it as a voltmeter? Now, for this to happen, the time base is switched off and the X plates earthed. So it implies that there will be no horizontal deflection. And now, the voltage to be measured is connected across the Y plates. Now, the voltage is calculated using the following formula, that voltage is equals to displacement times sensitivity. And sensitivity is given by volts per division. So when you use that formula, you can be able now to get the voltage that you want. Advantages of CRO over the common voltmeter. 1, it can measure large currents or large voltages without being destroyed. Number 2, it responds instantaneously. In other words, it does not take time. It can get the voltage at that instant, unlike the ordinary meters where the pointer is affected by the inertia. Then it can measure both AC and DC voltages. It has extremely high resistance, and this makes them, or it does not therefore alter current or voltage in the circuit to which it is being connected. Then it can be used to determine the frequency of an AC signal. And for this to happen, the signal is fed on the Y plates of a CRO with the time base on. Remember, as a voltmeter, the time base was off. But now when you want to measure the frequency, the time base is on. Then the time base control knob is adjusted so that it can give 1 or 2 cycles on the screen. Then from there, we have the setting of the time base. Remember, we gave an example of typical setting. We can have 10 milliseconds per division, or per centimeter, or 100 milliseconds per centimeter. So by tracing the cycle or the signal on the screen and relating it with the time base setting, then you can be able to get the frequency. And the frequency will be given by F is equals to 1 over T, where T is the time taken for a signal to appear, or what we call the periodic time, the time for one signal. Then from there we have problems on CRO, and we start with example 1. The figure below shows a display of an AC signal on a CRO screen. Determine the frequency given that the time base setting is 200 milliseconds per division. We have this as our display. As you can see in our display, we can be able to count the number of cycles. We have up to that position is 1 cycle. Up to that position again is another cycle. So we have 2.5 cycles. And we are given that the time base setting is 200 milliseconds per division. Again, from here to here, we can be able to count the number of cycles. So we proceed as follows. 1, the time base is given. Then the number of division for 1 cycle. We have given that the cycle, or the number of cycle, or the number of divisions per complete cycle, you can count them. In our case here, if you count, the number of division covered in 1 cycle is 1, 2, 3, 4. So 4 divisions, 1, 2, 3, 4, up to this position. That is 1 cycle. So you proceed as follows. We have that 1 division carries 200 milliseconds. What about 4? And milli is the same as 10 to the power negative 3. So 4 seconds, you multiply 4 times 200 milliseconds. And you get that it will be 0.8 seconds. That is the time for 1 signal. So to get the frequency is the reciprocal of that. So our F will be 1 over 0.8, and that will give you 1.25 hertz or per second. That is the frequency of AC signal. Then question number 2, or example number 2, if the time base control of CRO is set to be 10 milliseconds per centimeter, what is the frequency of the wave traced given that the wavelength is 1.8 centimeter? Now remember that the wavelength is the length, or it is the distance covered by one signal. So it implies that we can be able to proceed as follows. The periodic time will be given by the time for 1 centimeter, which is 10 milliseconds, multiplied by the wavelength, that is the distance for one signal, that is 1.8 times 10 times 10 to the power negative 3. When you multiply, you get that it is 0.018 seconds. When you get now, that is the periodic time. When you want to get the frequency now, it will be the reciprocal of that value, and that will be 1 over 0.018 second. When you divide that using your calculators, you will get that it is 55.56 per second, or what we call hertz, and that will give us approximately 56 hertz. Then we proceed to example 3. A DC voltage of 50 volts when applied to the Y plate of a CRO causes a deflection of the spot on the screen as shown below. It is moving up to 2.5 divisions. Then determine the sensitivity of the Y gain. We proceed as follows. The spot deflection on the screen is 2.5 division. Remember, you are counting from here. 1, then 2, then 0.5. It is at the middle. So it is 2.5 division. And we are given the voltage as 50 volts. So the number of division, or the sensitivity, is given by the voltage divided by the number of divisions. So you get your 50 volts divided by 2.5, you get that it is 20 volts per division, and that will give you the sensitivity of the Y gain. Then part 2, or question number 4. The figure below shows the trace on the screen of an AC signal connected to the Y plate of a CRO with the time base on. That is the screen. Given that the time base control is 5 milliseconds per division and the Y gain is at 100 volts per division, determine 1, the frequency of AC signal, and number 2, the peak voltage on the input signal. So in other words, we are supposed to get the peak voltage here, and also we get the frequency. And as you can see, you can be able to get the number of cycles, and from the number of cycles you can as well get the number of divisions covered or traced by our cycle. So we proceed as follows. 1, the time base is given as 5 milliseconds per division, and the number of division covered is 8. So to get the total time, it will be 5 multiplied by 8 to get that it is 40 milliseconds. That is the total time taken. But this is the same as writing 40 times 10 to the power negative 3 seconds. But we have 2 complete cycles. So to get the number of one cycle, you divide by the number of complete cycles. So you get the total time, you divide by 2. When you divide by 2, you get that it will be 20 times 10 to the power negative 3 seconds. Remember, this is supposed to be the power to power negative 3. So when you divide it, it will be 20 times 10 to the power negative 3 seconds. Then from there, you want to get the frequency. And the frequency is always given by 1 over t, or 1 over periodic time. You have your periodic time as this one. So you just need to get 1 divided by 20 times 10 to the power negative 3 seconds. When you do that, you get that it will be 50 hertz. After that, part B, you are supposed to get the Y gain. And the Y gain is given, you're supposed to get the peak voltage, but the Y gain is given by 100 volts per division. So the deflection is 3 divisions from the 0 level. So the peak voltage will be Y gain times the number of divisions. So it will be 100, that is 100 volts per division, multiplied by the number of division, which is 3, to get that it is 300 volts. That way, you get your peak voltage as 300 volts. Then from there, we have the assignment. Again, we always say that practice makes perfect. So go through the problem solved several times before you attempt the calculations on our assignment. So thank you, and prepare for the end of topic exam. Let us meet in our another topic.